Okay, welcome back to part 4 and the final part on this lecture series on combinational logic circuits. Okay, so far I've been teaching you about how to get the SOP from a circuit, and then the other way how to draw the circuit from an SOP, and then the third part was that I taught you how to simplify the SOP and the final circuit, right? In this last part, I'm going to teach you the context as to why we do all of this. So the whole reason why we do all of this is to solve real life problems. Okay, so this is the context of why we are doing it. So any problem, if a problem, not any problem, if a problem I can't solve any personal emotional problems, but uh, problems that we can solve using logic gates, we can build, right? And if we can build them, we can implement them. So for example, let's look at this work example 12.7. The relay match wants to generate a list of participants to qualify for semifinals, so yada, yada, yada. So they need to be able to complete any two of this task, any two of this. So they either do this or this, or this or this, this or this, and well, you get it, right? So they need to complete at least two. So the first thing is let's assign an alphabet to some of these things. So I don't know what alphabet they assign, so they call it A, B, C, right? So A, B, C. A, B. Okay, so same thing, you draw your truth table, 4 ones, 4 zeros, 4 ones, 2 zeros, 2 ones, 2 0, 2 1, 0 1, 0 1, 0 1. This is standard. And then from here, the output will be a 1 if any two of the inputs is true. Remember, they just need to complete any two. So long as so long as any of the three inputs out of the three, two are correct, true, the output will be a 1. So in this case, BC, AC, AB, and of course, if you complete all three, needless to say, you're the best, you're the bomb, you're into the semifinals. So I have 4 situations whereby the output will be true. And after this, remember, we can straight away implement the solution, no problem. But I already taught you how to simplify the expression, and let's go ahead and simplify this now. So first thing, draw a K-map, solve for the loops, and after you get the loops, this is the expression you will get. And after getting the expression, you can actually implement the circuit like so. So it's as simple as that. Okay, so from start to end, that's the whole general idea. Okay, let's look at question 2. Question 1, majority of the inputs A and B are 1. Majority means 2 out of 3. It will be exactly the same as this. Yeah, so let's look at this. Yeah, a manufacturing plant sounds an alarm when either or both of the following conditions occur. 1 or more machines are running after operating hours. 1 or more machines are running during weekends. Okay, so either this or both. So they are very nice. They give me the 3 inputs. A is during operating hours, and 0 is after operating hours. Okay. B during weekdays, and 1 during weekdays, 0 during weekends. And C, when 1 or more of the machines are running, or 0 when all machines are switched off. Okay, so the first thing is, the output is sound the alarm only when X is 1. So these are the conditions. First of all, I'm going to set up the truth table. I'm going to draw it, so I don't want to waste time. I'm going to pause the video here. You do it along. Draw the truth table right now. Okay, pause the video, draw the truth table. Okay, so I've already drawn the truth table. This is it follows the usual setup that I taught you to do. So the very basic thing is you must be able to set up the truth table on your own like this. 4 zeros, 4 ones, 2 zeros, 2 ones, 1 0, 1 1. Okay, and then let's look at a situation. All right, so the alarm X will ring, and rings means X is 1 when either or both of this situation occur. So one or more machines are running after operating hours. So first of all, when machines are running after operating hours, so A is 0, during B is 0, okay? So I'm looking at when the machine is running, when C is 1, so I've got 1, 1, 1, 1, okay? But that doesn't mean that this will be 1, because it could be running, during weekdays, which is, yeah, it makes sense, right? Weekdays the machines need to be running. So during weekends, or let's do the A first. During after operating hours, that means everyone's gone home, but then wait a minute, the machines are still running. Something is wrong. Sound the alarm. So we don't want that. So yeah, so when A is 0, is A 0? Yes, A is 0. So it is after hours and the machine is running. Sound the alarm. So let's look at this. Is A 0? Yes, sound the alarm. Is A 0? No, so we don't. Is A 0? No, so we don't. Okay. Now let's look at B. During the weekends, machine is running. So during the weekends, we want B to be 0, right? During the weekends, this is already 0. It's already sounding the alarm, so that's cool. This is already sounding alarm. This one, it is a weekend. So even though it is during the office hours, but it is during office hours on the weekend. No one's supposed to be working. Why are the machines running? Sound the alarm. And this one, no, it is during weekdays, during office hours, machines are running, that's fine. Okay, so the alarm will only sound during these 3 situations. Okay, so we've come up with the, and so now what we need to do is we need our K-map in order to simplify this expression. I'm going to pause the video. Do pause the video too. Set up your K-map right now. Okay, so I've drawn the K-map. Now let's populate this K-map here. Okay, 0, 0, 0, 0, 0, 0. It is 0, 0, 0, 1, 0, 0, 1. It is a 1, 0, 1, 1. 0, 1, 1. It is a 1. 0, 1, 0, 0, 1, 0. It is a 0. Now 1, 0, 0. 1, 0, 0. It is a 0. 1, 0, 1. 1, 0, 1. It is a 1. 1, 1, 1, 1, 1, 1 is a 0, and 1, 1, 0, 1, 1, 0, it is a 0. Okay, so we've populated this K-map. Now, I want you to pause the video now and come up with the SOP expression right now. Pause the video, do it. Okay, so I hope you didn't cheat. I hope you paused it. And right now I'm going to come out with the loops. All right, so let's use a very nice purple color to come up with the loop. So I have one loop here and I have one loop here. So right now, let's study this loop first, this vertical loop here. So A is not common. A changes from 0 to 1, so I don't want A. And I want both B complement and C, right? Because that B complement and C is common for this loop here. So I want B complement and C, or I have another loop, or, so now A complement is common, right? So A complement and B changes, so I don't want B. I want the one that's common. So C. C from here to here is still 1. So, and C. Okay, so I've simplified the expression I would have gotten if I gotten it from this truth table. I've used a K-map to simplify it. Now I want to implement the circuit. So pause the video here again. Try and see whether you can draw the circuit. I'm going to do it on my own. And when we come back together after you finish drawing, press play again and we'll see whether we get the same circuit. Okay? Okay, so this is what I came up with. All right. Yeah, so this is my solution. for the problem of the factory sounding an alarm. Yeah. So I don't know what sort of component they'll use in order to get these sensors A, B, C, right? But I do know the output here, I will have to connect a buzzer. Okay, so I have to connect a buzzer at the output here, and when any of this this circuit will help me sound the buzzer when it is the office hours. Okay, so I can build a prototype on this, set up a buzzer, set in the sensors for the 3 inputs, and I'm good to go. So this is how we use logic gates to help us solve problems. Okay, so I've just a very quick summary. From the start, I've taught you what are logic gates. Yeah, and this is in chapter 11. What are logic gates? What are universal gates? How what truth tables are? What are the Boolean expressions? And then come chapter 12, I taught you how to mix and match different gates, combine them, combinational gates. I've taught you how to how to derive the SOP from the circuit, and vice versa, how to get the circuit from the SOP. And I've taught you how to simplify the SOP expression using K-maps. And lastly, I've taught you how to apply all of that into finding a solution for a real world problem, giving you the context. Okay, so lots of examples in your worksheets. Please go and try them out. Again, if you have any questions, you can email me, or you can look for me in school, and I'll be more than willing to help you out there. Okay, so hope you have learned something, and I will see you next time.